Good evening, guys. Welcome to Gradeup, India's biggest e-learning platform. So I welcome you all to this live session of Theory of Machines, the first topic of Gears 1. So please respond to me so that I could get to know that you are live with me. Yes, anyone? Very good evening. Anyone who is live with me, please respond. First of all, do let me know whether the network is correct or not, so that we could have some personnel who will be rectifying any issues if you are having. Very good evening. So welcome to Gradeup, India's biggest e-learning platform. So I welcome you all to this live session on the theory of machine topic, the Gears 1. And in the previous class, we have discussed about the acceleration analysis and also about the velocity analysis. So today we'll be having the first topic of the gears. In today's class, we'll be having only the basic idea of gears. Also, we'll be discussing about the classification of gears and also about some basic terminology associated with the gears topic. So please respond to me. Those who are live with me, they just need to type it or just give me message. Very good evening. Okay, so is the video clear? Audio is clear? Please tell me, respond to my question, because then only I'll be starting today's topic of gears. Yes, please respond to me. Good evening, guys. Good evening. Okay, now let us start today's topic of gears. Now, before starting the topic, I would like to tell you a very basic thing about, because we have now switched to this platform only due to the coronavirus. Okay, so I request you all, will be having some sessions like this for the next 1 week or 2 weeks. We'll be having session like this so that your preparation doesn't get hampered. Okay, and if I want to tell you about how to wash your hands, because this is mandatory and Government of India has also give and mandate that you need to give information about coronavirus. So how do you will be protecting yourself against the infections? Just there are 12 basic steps for washing your hands. So definitely you can go with this step-by-step procedure. Like if you talk about the step 1, you need to wet your hands, then you need to apply the soap, then there are some movements of the hands which is given. You need to follow this step only so that you are safe and you are healthy. Okay, and if I talk about the helpline number, if you or anyone else nearby to you is getting any symptoms of coronavirus, you definitely need to call to this number. Fine, so that the guidance or help or technical queries, anything which you are having any doubt, you can contact to this number. They will be clarifying your doubts. Okay, clear? Now let us start today's topic about the gears. Now, if I introduce myself, my name is Sooraj Gopi. Most of you might be knowing about me. My name is Sooraj Gopi. I have 5 years of teaching experience. The main area of expertise is mechanics, thermal applied, heat transfer, industrial engineering, and theory of mechanics. Okay, so let us continue the topic of theory of mechanics, the topic of gears. Now, please, I want you all to please respond quickly so that I'll be getting to know how many are able to understand. Now, my first question for the today's session is, what do you mean by gears? Yes, anyone who can tell me what do you mean by gears? Yes, anyone who can respond to my question, what is the definition of a gear? Because without knowing the basic definition of gears, it is difficult to start the topic. Okay, so tell me, what do you mean by gears? We'll be having a basic discussion of the gears topic, and I want you to please respond, because I'm not getting any response from your side, which is very disheartening. So I want your response so that we can start this session of the topic of gear strains. Yes, yes, it's lagging. Okay, very good. Now I'm audible or not? Video is lagging. Fine. Voice is clear. Video is lagging. Fine. Good evening. Please respond. Now I'm okay, clear, so that I can start the topic. Okay, Amit Gunda, Babu Rao, Soheb. Yes, very good, Amit. Now, very basic definition of gears. If I talk about the basic definition of gears, the definition of gears is to transmit. It is basically used to transmit power. Okay, it is basically used to transmit power. So gears, the basic application of gears is power transmission. Now we can transmit power by using different modes. Why only gears? Anyone who can tell me why we are only using gears for the power transmission? Any speciality of the gears? Anyone? The machine is used to transfer power. Very good, Gaurav, Venugopal, Lucky. Good evening. Now, why we are using gears? Anyone who has the explanation? Exactly. Now, gears are basically used whenever we need to transmit power with very minute losses, or we can say where we need to transmit power when the losses are very less. Then only we are using gears. Okay. Sir, video is lagging hugely. Okay, fine. So I don't think so. Now it's lagging. Please respond to me, because this is the first class which I have taken like this. No slip. Very good. Now, if I talk about gears, gears are basically the transmit power where there is no slip. Got it? Yes. Very good, Mohammed. Slip problem is not there. Very good. Now, if I talk about the drive, there are basically two types of drives. The first is positive drive, and the second one is a negative drive. Okay, so there are basically two types of drive. One is positive drive and second is negative drive. Now, what do you mean by positive drive? Anyone who can tell me what is the meaning of positive drive? Pawan, actually we are now shifting to this due to the coronavirus. We'll be also working from home like all other platform, because we need to give information, we need to give classes for you guys only. So by any means we'll be coming to in front of you with the live classes, either on the smart board or by using pen tablet. Okay, fine. Now I'm extremely sorry for that. I'm not able to take class in this because due to, I'm again repeating, it's only due to coronavirus. We are not able to go like the real classes which we are having. So that is why we are coming like this, so that your preparation is not at all hampered. Okay, fine. Now, fine. So positive drive is basically that power transmission medium in which there is no slip. Okay, when there is no slipping, if I talk about this, when there is no slip, then only we are using positive drive. Okay, where the slipping is not possible. Now, if I talk about the negative drive, negative drive is basically those power transmission medium where the slip is there. Okay, where there is slip criteria. Is that clear? Fine. Where there is a slip criteria, there will be having the negative drive. Now, can anyone who can give me an example? What is the example of a negative drive? Anyone? What is the basic example or any example of negative drive where slip is provided, or we can say where there is slip or there is positive or negative slip? So it is basically, you all know, belt drives, rope drives, chain drives. These are basically those power transmission medium where your slip is being provided, or there is slip between the power transmission. Fine. Is that clear? If you talk about this, I've given you some examples over here: belt drives, rope drives, gives chain drives also. These are all the examples of a negative drive. Clear? Fine. All of you know, because when a gear, like there are two gears, okay, there are two pulleys over which we are having a belt. Fine. If there is a power transmission on the one of the pulley, so we'll be having slip criteria on the power driven shaft. Is that clear? So belt drive is the best example to understand the negative drive. Fine. Now, if I talk about there are two gears. Let us suppose there is gear 1 and gear 2. There are two gears. This is gear 1 and gear 2. And we are having a point of contact. Let us suppose this point of contact is P. Clear? Now, if I want to say there is no slip, what should be the criteria? Please tell me. Sometimes there is like 90% of the time they are taking the chain drive as positive drive, but sometimes due to some bearing issues you can get some slip. Okay, so due to that we also take the chain drives into the negative drives. Clear? Fine. Now please tell me, if I am talking, there are two gears. This is gear 1, and there are gear 2 which are having in mesh, and the point of contact is this P point. Now tell me, what will be the criteria if you want to have there is no slip? Yes, exactly, very good. Anyone who can tell me what will the criteria for no slip condition? For no slip condition, we are having a very basic criteria. That means if I talk the velocity of P, if you talk about what is the velocity of point P in terms of gear 1, that will be R1 into omega 1. Is that clear? That will be R1 into omega 1. You're not able to see it. I'm writing once again for you guys. So V, if I talk about VP, one second guys, there's some issue with this. Yes. Now, if I talk about VP is equal to R1 into omega 1, this is the velocity. This is the velocity of point P. What is point P? This is point P. This is point P. So VP is equal to R1 into omega 1. And also we can define the velocity of point P. What is the velocity of VP? This is basically this velocity. This is VP. Okay. Now we can also write VP is equal to R2 into omega 2. Clear? We can directly write. Now, if there is no slip condition, what we can say? We can directly say as R1 omega 1 is equal to R2 omega 2. Is that clear? This is a no slip condition. If I am saying the two gears are in mesh, the no slip condition is omega 1 R1 is equal to omega 2 R2. This is the most important formula because you will be using this formula in the gear trains when we'll be having a bunches of gears in mesh. We'll be calculating the ratio of omega and R. Clear? So that means what's the meaning of this? That means omega 1 by omega 2 is equal to R2 by R1. Is that clear? Is that clear? So that means if you're having a sir, यहाँ से classes continue रहेगा? Yes, for 1 week or 2 weeks, like till this corona effect is not being decreased, the classes will be going on like this. But today is the first class, so that is why we are having some issues with the server. But definitely in the later on classes we'll be having a smooth and buffer free classes. Okay. Fine. So now you have understood gears are basically the positive drive. What is positive drive? When there is no slip condition or when there is no slipping between the two driving and the driven gear, that is known as positive drive. Clear? So, and what is the meaning of no slip? No slip means you'll be having the velocity of point P. If I talk about this point, the velocity of this point P will be same if I talk about with respect to gear 1 or with respect to gear 2. Clear? Fine. Understood basic definition of gears. Now, if I talk about the classification of gears, now we'll be discussing about what is the different classification of the gears. That is very important for understanding how we can define gears based on different criteria. Okay, now let us discuss about the very basic or the first classification of the gear, that is according to the axis of shaft connected. Definitely, because what is the application of gears? You need to transmit power from one shaft to another shaft. That is your application. Okay. Now, the first classification is classification according to the axis of the shaft being connected. The first under this heading is both shafts are in parallel, or that means both shafts, the power transmit. That means the driven shaft and the driving shaft, the shafts are parallel to each other. Fine. Now the video is going good. Thank you. Hello, Satya sir. Now, the basic application, basic example is, let us suppose there are two gears. Let us suppose there are two gears. There are like the red one is gear 1 and this one is gear 2. The black one is gear 2. Now, these two shafts are parallel to each other. These two shafts are parallel to each other. So, this is the first classification when the both shafts are parallel to each other. And this gear types is basically known as, very common type is known as spur gears. So that means whenever if we want to transmit power between two parallel shafts, we can go for spur gears. Okay, fine. Now, but can anyone tell me whether we are using spur gears in every application or every machinery, or is there any drawback to this gear? Anyone? Is there any drawback for this spur gear? Because if I say spur gears, normally in industrial application we are using approximately 2% only. We are using only approximately 2% in the machineries. The spur gears is being used. Fine. Why? Because if we are using two high-speed spur gears, what will happen? We are having a very basic term, that is instantaneous engagement and disengagement. Now, what will happen if, for example, there is gear 1 and there is gear 2? If we are having an instantaneous engagement, let us suppose this is gear 1 teeth, this is gear 2 teeth, they are having an engagement like this. So, what will happen? So, if there is an instantaneous engagement and disengagement, we'll be having a high impact stresses. Okay, so we'll be having high impact stresses. That is why we are not preferring spur gears. Fine, that is why we are not preferring spur gears. Approximately we are using 2% or 3% of the gears, the application of spur gears, where the cost or we can say where the power transmission is not that high. Clear? So it is basically used when we want to power transmit, or we want to transmit power which is at low RPM or low speed. That is the main application. And also very good, large distance is not possible. Definitely Babu Rao is correct. If you are transmitting power only by using two gears, then you let us suppose I want to transmit power which is at a distance of 10 meters. So in that case you need to have a diameter, a very huge diameter, which will increase your cost. And also what will happen if the smaller gear is very small? Let us suppose there are two gears. This is very small, another gear is very big. Okay, fine, and these two are in mesh. So what will happen? The impact or the inertia force of this bigger gear, the impact force of this bigger gear over the smaller gear will be very, very high. There are chances like the tooth will be damaged. Very good, Amit. The tooth will be damaged. Okay, definitely. If I'm saying the RPM is very high of gear B and gear A, let us suppose the bigger gear and the smaller gear A is having a very high RPM. So what will happen? We'll be having high inertia, or it will be having like this. Let us suppose this is gear 1, this is gear 2. Every time we'll be having an impact. So there are possibilities like the teeth will be damaged. So that is why we are not preferring spur gears. Now, there is one advantage. Always in every gears we're having some advantage and disadvantage. Okay. Spur gears are having no axial thrust. That means that is the most beneficial point which we can get. But due to this impact stresses, we are not preferring spur gears. No, Amit, we are not using spur gears. Instead, we are using your helical gears like this. You are using helical gears. You can see any gearbox. Fine. In motorcycle, no. In motorcycle, any automobile, we are not using any spur gear. We are basically using helical gears. You can see in your colleges, you might have seen your IC engine workshop. There you might have come across a gearbox system, and you can see there are basically gears which are having arrangement something like this. Let me show you over here. We'll be having an arrangement something like this. Gear 1, this is gear 2. We'll be having some inclination like this. Fine. Fine, exactly. Excessive noise. If you're having impact, very high impact, so what will happen? The tooth might be broken. Fine, the tooth will be damaged. The noise will be very high. So that is why we are preferring spur gears wherever we want to transmit power at low speed. Okay. Yeah. Now let us talk about the second. Under this is first one is spur gears. Now we are taking the same criteria whether the shafts are parallel. Now helical gears. What is helical gear? When we are having a gear, this is gear number 1 and this is your gear number 2. Okay, so teeth will not be parallel. It is basically will be having teeth like this and inclined teeth. Okay, so this is basically known as helical gear. Okay, so this type of gears is basically known as helical gear. Now, what is the advantage of this? Anyone? What is the basic advantage of using helical gear? Now, in this case, there is a basic, most important advantage is there is a gradual engagement. What's the meaning of this term, gradual engagement? That means if there is a gradual engagement, then there will not be any impact stresses. Is that clear? There is no impact stresses. Why no impact stresses? Because there is gradual engagement. If I talk about the previous one, in the previous one, there was instantaneous engagement and disengagement due to which we are having high impact stresses. We were having high impact stresses. Fine. What is pitch? Definitely we'll be talking about the gear terminology in today's session. So wait till the end of this session. We'll be having that. Okay. Ramesh Mon, no, you're not that much late. We have just started the gears topic. Okay. Now, stress distribution we'll be discussing in your strength of material topic. So don't worry. We'll be having step-by-step method. Okay. Now, but there is one disadvantage of helical gear, that is they will be having an axial thrust. Okay, axial thrust basically means at this point, at this location, if I talk about here, at this location, this is your shaft 2, this is shaft 1. So we'll be having some stresses at this location, but don't worry, that stresses is not that much higher. So we are basically overcoming the disadvantage of spur gear, that is there is no impact stresses, the most important point. So that is why helical gears, if I talk about the application, 90 to 95% of the machinery are using helical gears. Why? Because we can use at higher speed, and in your gears we are basically using to transmit power from one high RPM shaft to the lower RPM shaft. Okay, or lower RPM shaft to higher RPM shaft. Okay, is that clear? Now, but every time we need to when you see any machinery, we always go for the best machine. Okay, now there is one advanced version of helical gear, that is the double helical gear. If I talk about double helical gear, this is basically also known as herringbone gear. Herringbone gear is also located. Fine, is the other nomenclature of this. So basically these are also used because there is no axial thrust. Is that clear? So there is no axial thrust in case of herringbone. So that is why we are preferring herringbone, but the cost is very high. So that is why maximum number of times we are basically using helical gears over your double helical gears. Is that clear? Stress distribution, will be having stresses at the axial. We'll be having axial stresses, but axial stresses is not that much hazardous to the gear if I compare with the impact stresses, because impact stresses directly breaks your teeth, which directly damages the application, which if the tooth is broken, what will happen? You cannot use the gears. Is that clear? Shaft location is different. No, it's not different. We are having parallel shaft. This is shaft 1, shaft 2, this is a parallel shaft. If I talk about this is shaft 1, and let us suppose they are having other gear like this. This is shaft 2. So these two are parallel to each other. These two are parallel to each other. Okay. No, how impact stresses are no, why? Because we are having a gradual engagement. Initially, if I talk about spur gears, what was happening? We were having a complete gear in contact with this gear. So at a time the surface area is increasing. But if I talk about this, at a time only this portion is in contact. So what will happen? It's a gradual engagement and disengagement. If any two materials are having a gradual engagement and disengagement, definitely they will not be having any impact stresses. Fine. Yes, contact area same, but at any instant the area of contact or the point of contact is less. If I talk about spur gear, you can see directly in the spur gear, the whole teeth is contact with the another teeth. So what is basically happening? The complete teeth is in contact. If I talk about your helical gear, we are having only gradual engagement. Lubrication is must, sir. Sometimes we are using, because what happens, we are having gradual engagement, that doesn't mean the impact stresses will be nullified. Fine. If there is some amount of gradual engagement, because we are normally preferring the gears over very high RPM. So if you are using at very high RPM, what will happen? The minute engagement or minute stresses will be very enhanced. Fine. That is why you might have all talked about your endurance limit in machine design. Okay, fluctuating load. Fine. So in that case, what happens? If a body is in fluctuation, is in motion, the stresses are basically is lower than that of the failure stresses. Clear? Fine. So that is why, because these are the material, these are the machinery which are always in motion. So whenever a body is always in motion, we are basically talking about endurance stress, not the your shear stress or tensile stress or compressive stress. Clear? Fine. Understood. When your both the shafts are parallel. Now let us discuss about when they are not parallel. So we can, one of the criteria is both the axes are non-parallel but intersecting. Okay. So this is basically, we are having very common example is bevel gear. That means we are having non-parallel axes but they are intersecting to each other. Okay, so this dotted line is basically the shaft 1 and this is your shaft 2. This basically represent the center of axis of the shaft. Yeah. So if anyone asks you which is the type of gear in which we are having non-parallel but intersecting shafts, this is basically the bevel gears. So if we want to transmit power from between two axes which are intersecting but not parallel, in that case we'll be using bevel gear. Now tell me where we are using bevel gear, please. Anyone? You might have seen bevel gear in many of the applications. Anyone? Very basic thing you might have seen. Please tell me where you have seen the application of bevel gear. Anyone? Because bevel gear is very commonly used, and I presume more than 90% of you all guys might know about where we are using the bevel gears. Anyone? Bevel gears basically used when we the axes are intersecting but not parallel. 30-degree angle, sir. It can be anything. If you want to have a perpendicular also, you can have a perpendicular like this. Let us suppose this is your axis. Okay, this is your bevel gear 1 and this is your another axis. This is your bevel gear 2. Okay, this is your bevel gear 2. This is your bevel gear 1. So we are basically transmitting power from this shaft to this shaft. Okay, so we can have your 90-degree also. Very good, Mukesh. Differential gear. Yes. Anyone who can tell me where we are using differential gears? We are using differential gears in automobiles. Please, I hope you remember the automobile topic which some of the students might have studied in the final year. Okay. Okay, fine. So we are basically using bevel gears, like all of you might be using, might have seen the differential gear which is used in automobile. Okay, clear? Now, pure rolling can be transmitted between two conical surfaces in contact. So basically we are having, this is the point of contact, and in this point of contact we are having a pure rolling criteria. Power transmission works. Yes, definitely. Vehicle differential. Yes, very good. You all guys know the application. The only thing is you just need to remember what is happening. Okay, fine. Let us talk about if you are having axis is neither parallel and not at all intersecting. So in that case, please remember pure rolling is not possible, and the type of gear which we are using is the spiral gear. The spiral gear is big, or also known as skew bevel gear. Fine. Steering, very good. Steering, in steering also, like Mayur is saying, in steering we are using differential gear. Okay. Fine. Now, in this case, pure rolling is not possible. You can see the profile of this. It's not a straight line. It's a curve. Okay. So the pure rolling is not at all possible in case of spiral gear. Okay, in case of spiral gear, the pure rolling is not possible. But if you want to transmit power between two axes which are not parallel and not at all intersecting, then you will be preferring the spiral gear. Is that clear? Fine. Now let us discuss about one of the very commonly used worm wheel. Anyone who knows what do you mean by worm wheel? Worm wheel is basically, will be having a thread-like structure in one of the shaft, and will be having teeth over here on the wheel structure. So it will be basically transmitting power in perpendicular direction. That means if you see, the axis of this shaft is in this direction and axis of this shaft is coming outside the board or outside your mobile. Fine. So we are having a shaft like this, another shaft like this. So basically they are parallel to each other, but they are not intersecting. Fine. So worm wheel is one of the classification of gears. Now, example spiral gears. I'll be showing you the live image, and there I'll be showing you the spiral gear. You might have come across this type of gears. Okay. Worm wheel. Anyone who can tell me where we are using worm wheel? No. Look, real life example. If it basically depends how you want to transmit power. Okay, that basically depends upon how you want to transmit. Let us suppose if you want to transmit power between two parallel shafts. Okay, two parallel shafts which is not intersecting. So basically I'll be preferring the bevel gear, which is two parallel your parallel shaft which is not intersecting. It is your worm wheel. Fine, because in worm wheel what is happening, it is two parallel shafts but they are perpendicular to each other, so we can transmit power. So real life example is basically it depends upon the boundary condition, or it depends upon the configuration, how you want to transmit power. If the two shafts are parallel to each other, you definitely will be preferring helical gear. Okay, if the two shafts are not parallel, not intersecting, in that case you'll be using the spiral gear. Okay, fine. Now if I talk about worm wheel, the most important feature of this, it's having a very high speed reduction ratio. Now what's the meaning of this? What's the meaning of this term, very high speed reduction ratio? Drilling machine, yes, definitely we are using there. Anyone who knows what is the meaning of high speed reduction ratio? Mukesh, Mayur, Babu Rao, please tell me, or Salman, what is the meaning of speed reduction? Basically, what is the meaning of this? Let us suppose I'm using two spur gears. Let us suppose, or two helical gear. We're having two helical gears. Okay, this is your gear number 1. This is gear number 2. Fine. Now, if I want to decrease the speed, let us suppose this is rotating at 1000 RPM. Okay, the gear 1 is rotating at 1000 RPM, and if I want to reduce the speed to 30 RPM. 30 RPM, then what should be the diameter of this? If you see, omega 1 R1 is equal to omega 2 R2. Okay, now omega 1 I can write in terms of N. So this is 1000 into R1 is equal to, let us take this as N2 into R2. So that means what's the meaning? And if I want to have a 30 RPM, this will be 30. So let me remove this. This will be 30. Let us suppose take it as 50 so that your calculation will be much easier. Okay, let us take this as 50 so that your calculation will be much easier. Fine, this is R2. So that means what is the ratio of R1 by R2? R1 by R2, the ratio is, or R2 by R1, the ratio is, this will be 20. That means the radius is 20 times of R1. That means your R2 is equal to 20 times R1. Now, what's the meaning of this? If I want to reduce the power, if you want to reduce the RPM by 20 times, I need to take 20 times that of radius. That means the cost of that material will be very, very high. Fine, the cost of the material will be very, very high. If I want to transmit power from 1000 RPM. Let us take, I want to reduce the RPM from 1000 RPM to 50 RPM. Okay, so in that case, you will be using 20 times that radius. That means if that will be having high cost, and the and you won't be able to use in your high RPM. Why? Because what will happen if we are having a high RPM? It will be having again the impact stresses, and due to impact stresses, what will happen? The tooth will break. So in that case, whenever we need to have high speed reduction ratio, we are basically preferring the worm wheel. Is that clear? We are basically using the worm wheel whenever we need to have the high speed reduction. As you can see over here, we are having 30:1, 100:1, or even 1200:1. We are using the worm gears. This is the application or the importance of worm and worm wheel. Is that clear? Fine. Reduce the speed or the velocity. Exactly. Salman is correct. Understood the basic classification of the gears based on the configuration of the axis or the shaft. Any doubt, please tell me, or else we'll be going to the second classification, which is very easy. You will be seeing it is very easy. Okay, now let us go to the second classification. Second classification is based on the type of gearing. Based on the type of gearing, the first one is external gearing, the second is internal gearing. Very basic thing. External gearing means the two gears will be having an external mesh. The two gears will be having an external mesh, that is your external gearing. And normally, if you talk about sign convention type, the gear which is bigger in size, we are usually we are giving that terminology as gear, and the gear which is smaller in size, we are using the terminologies as pinion. Is that clear? Is that clear? No doubt. Fine. Internal gearing, very basic. One of the gear will be having external and other gear having internal gear. That means, if let us suppose this is your gear, this is your teeth, and we are having internal gears like this. So basically, it will be transmitting power from gear 1 to gear 2. We are having internal gear. This is your gear 1. This is your gear 2. We'll be having a transmission of power between the two gears whenever having internal gears. And if you see, if you talk about the previous one, this is the representation of the gears. This is shaft. This is your shaft, and this is your gear. Let us suppose this is your gear number 1. We'll be having gears like this, and this is your gear number 2. Okay, fine. This is your gear number 2. Clear? So internal gearing, external gearing, and the bigger gear is always known as ring or annular, because that will be using when we'll be studying gear trains. That is very helpful. When we'll be using gear trains, we'll be using if I say gear. So that means you by default you need to assume the gear who's having the higher diameter, that will be known as gear, and the gear which is having a smaller diameter will be known as pinion. Clear? Fine. This is where it's applied. It's basically used in you might have seen in clocks. In clocks also sometimes they are using internal gears. Yes, very important thing Salman has said to me, and I forgot to tell you about. Let us suppose we are having a gear over here. This is one gear, and this is your another gear. Okay, this is gear number 1. This is gear number 2. Now, whenever the two gears which are in external meshing, tell me, they will be having same rotation or different rotation? Let us suppose gear number 1 is rotating. Gear number 1 is rotating in a clockwise fashion. Clockwise. Tell me what will be the rotation of your gear number 2. Rack and pinion is also one of the type where the shafts are parallel and your non-intersecting. I'll be telling you rack and pinion also. Don't worry, in this slide only. Fine. Tell me what is the rotation of gear number 2. If gear number 1 is rotating in a clockwise fashion, tell me what is the rotation of gear number 2. Is it clockwise or anti-clockwise? Please quickly respond, because we need to cover a lot of things in this small session. If this is rotating clockwise, definitely it will be rotating like this. This will be a opposite direction. Very good, Babu Rao. Very good. It will be having an anti-clockwise. Mohammad Sagar, Gopal Yadav. Exactly, very good. Will be having an anti-clockwise direction. Clear? So please remember that whenever the two gears are having an external meshing, they'll be having opposite direction. So I'm writing over here so that you can understand. Whenever we are having external gearing, we'll be having an opposite direction rotation. Is that clear? direction rotation. Clear? So if I talk about internal gears, let us suppose your gear number 1, which is your this is your gear number 1, and this is your gear number 2, which is your internal gear. So if the internal gear is rotating in a clockwise fashion, definitely the bigger gear will also rotate in a same direction, which is clockwise. That means whenever we are having internal gearing, we'll be having same rotation. Clear? Fine. This concept will be using in gear trains, because in gear trains we'll be having a combination of different gears. Okay, whenever we're having combination of different gears, this is known as gear trains. So we'll be using this concept in your epicyclic gear trains in detail. Don't worry, we'll be solving a problem also in the live class in that session. Clear? Fine. Now which gear in same direction? Okay, let me talk about this. Let me tell you. Let us suppose, again, let me remove this everything. Let us suppose this is your gear. Let us suppose this is your bigger gear. Okay, this is your bigger gear. This is the center of this gear, and this is your smaller gear. Okay, this is your smaller gear, which is gear number 2, and this is gear number 1. Okay, now if gear number 2 is rotating in a clockwise direction, definitely gear number 1 will also rotate in a clockwise fashion. Now it's clear. Gear के numerical अच्छे लोगे कराना. Yes, I'm planning for taking a numerical in gear trains, because gear trains is one of the most important topic, and every year you can expect a problem from gear train. Like this year also, you might have seen a very easy question came in GATE 2020 about the gear trains. Yes, same direction. Salman will be having same direction. Okay, so please remember, whenever you're having an internal gearing, we'll be having the same direction of rotation, and if we are having opposite direction, we'll be having, whenever we're having an external gearing, we'll be having an opposite direction. Clear? Now this image basically gives you the idea how the real life gears is looking. Now if I talk about the first gear, this is your spur gear. Okay, this is your spur gear. You can see the teeth are straight. This is basically known as spur gears. Okay, these are spur gears. This is helical gear. You can see the teeth are somewhat inclined or having some angle. Okay, now this is your double helical gear, or we can say herringbone gear. You can see we're having two inclined sides. This is your herringbone gear. Spiral bevel gear. Now students ask me spiral bevel gear. Now you can see, and now tell me where we are using this type of gear, spiral bevel gear. You can see, now you can understand the spiral bevel gear, because this is very important. Some of the students are not able to visualize how these gears looks like. Okay, so that is why I've taken up a practical, a real life pictorial view of the gear, so that you can understand. So this is your spiral bevel gear, and like there is, the axes are non-intersecting and non-parallel. Okay. Clear? Now in this case, this is meter gauge. This is basically also known as your differential gear. This is used in automobiles. This is your straight bevel gear. We are having straight teeth. It's a similar type of bevel gear. It's a modified version of this. It's a modified version of the spiral bevel gear. Okay. Clear? Now if I talk about internal, now you can see internal gearing. Everyone able to see internal gearing? This is your worm wheel. And the students have asked about rack and pinion. Now, yes, exactly, differential. Rack and pinion. This is your rack and pinion. Tell me, what is the diameter of the shaft, or we can say, if this is your shaft 1, this is your shaft 1. So this, the pinion, so the rack will be having the location of the shaft in the infinity. Why? Because it's a single straight line. It's a straight line. Fine, it's a straight line. So we'll be having this pinion moving, rotating like this, transmitting power in the rotation direction. Tell me, what is the application of rack and pinion? Yes, exactly, very good. Kuldeep, vehicle ke wheel mein lagta hai. Yes, definitely there. You all know the application. Just I am giving you the basic idea how this gear looks like, because that will give you a clear image. Like if you see the rack and pinion, if you talk about rack and pinion, tell me where we are using this type of gears. Anyone? Where we are using this type of gear, rack and pinion? Anyone who can tell me? The application of rack and pinion, you might have gone to your workshops in your during your first year of B.Tech. You might have seen these type of gears in your workshop. Definitely, guaranteed, you might have seen rack and pinion. This is basically used if I want to transmit the rotational movement into your translation movement. Lathe, very good. Ramesh Mohan is correct. This is basically used in lathe machine. Might have seen, like there is a wheel which you need to set it, feed it. The cutting tool need to be feed it into the work piece. You might have used the lathe machine. Exactly, we are basically converting the rotational motion into the translation motion or linear motion. There we are using rack and pinion. Yes, exactly. Leg screw mechanism. Yes, very good. All of you know the application. Just only thing is you need to remember the application of this. Okay, clear? Fine. So these were the different classification of gears. We have understood different classification of how these gears are classified and how what is the application of different types of gears. Is that clear? Steering machine. Yes, definitely we are using a steering machine also. Very good. Clear? Any doubt? Please tell me, or else I will be going to the next section of gears. Spindle in drill machine. Yes, definitely we are using this. We are using your rack and pinion. We are definitely using this rack and pinion over here. Clear? Steering system. Yes, yes, very good. Now let me talk about how a gear looks like. Now let us talk about very basic term, very important also exam point of view, the gear terminology, because in this diagram we'll be spending some 5 to 10 minutes to understand what are the different nomenclatures. Okay. Now let us understand the gear terminology. Now we are having two gears. This is the teeth of the gear, which I am drawing with a red marker. This is your teeth of the gear. Okay, this is a three-dimensional view of the teeth. This is your teeth. Fine. So there are two. We will be having many teeth. We will be having many number of teeth. So these are the two corresponding number of teeth. So the top portion is known as top land, and this width is known as face width. Okay, this width is known as face width. Now, anyone who can tell me for specifying or because everyone will be having some specification. We'll be talking about nomenclature. Yes, definitely. Now, if I want to define a gear, what on which grounds we are defining gear? Do we define on the basis of how we are transmitting power? If I'm having a single gear, how to do the nomenclature, or which parameter is used to nomenclate a gear? Anyone? Mukesh, very good. Mayur, please tell me. Harsh, what is the nomenclature? Exactly, Mukesh, very good, very good. Exactly, we are basically using pitch circle. We are using pitch circle to do the specification. If I want to do the specification of gear, or if I want to nomenclate or nomenclature of gear, or if I want to specify any gear, we are basically specifying on the basis of pitch circle. Now, what is this pitch circle? Okay. No, Ankit, we are not defining on the number of teeth. We are basically defining on the pitch circle. Okay, by using pitch circle, we can define number of teeth. Yes, and in the pitch circle, we are having module also. Okay, very good, Ankit. Module, Ramesh, Mohan, very, very good. Fine. So if I talk about, there are three circles in a gear. We are having three circles. The one is pitch circle, second is addendum circle, and third is dedendum circle or root circle. Sometimes in some of the books they are using as dedendum or root circle. Now, what's the meaning of this addendum, pitch, and root circle? Now, you can see if I talk about the addendum circle is basically the circle which is passing through the top face. The top face of the teeth is basically passing through this. This is known as your addendum circle. Okay, so this is the circle which is passing through the top of the teeth is known as addendum circle, and the circle which is passing through the base of the teeth, this is your base of the teeth, this is known as dedendum circle. Is that clear? Is that clear? Now, what is this pitch circle? pitch circle is basically an imaginary circle. If I talk about the pitch circle, let me talk about in detail. So pitch circle is basically an imaginary circle. Let us suppose we are having a gear 1 and a pinion 2. Fine. So it is an imaginary circle. That means at this point of contact of imaginary circle, let us take this point P. So at this point we'll be having a pure rolling condition. Pure rolling condition or criteria. Okay, so you can see it's an imaginary circle in the gears where pure rolling of motion is absorbed when rotating gears are transmitting powers. Is that clear? Fine. So at this point, let us suppose the teeth of this gear is having it's having a contact at this point. Let us suppose this is the point where we are having a contact of these two teeth. It will start its contact from this point and will end. Let us suppose this is the ending point. It will end at this point. So between this, we'll be having an engagement like this. At this point, we'll be having pure rolling. So this point is known as pitch point. Very important. This point is known as pitch point or fixed point, which is the most important point in your gear terminology. Fine. And if I draw a tangent, if I draw a common tangent at P, fine. And if I draw this line of action of force, what is line of action of force? That means your gear is moving. Your engagement and disengagement occurring at this line. Your engagement and disengagement is occurring along this line. That means if I take this point Q, and if I take this point, let us suppose this point is N. So your gear will start its engagement from point Q. Point is known as start of engagement, and your point N is known as end of engagement. Is that clear? Now, what's the meaning of this engagement? I'm saying the end of and start with. That means let us suppose my two hands, this is your one of the teeth of the gear, this is second teeth. So when it will be transmitting power, what will happen? We'll be having some point of contact between two gears. So always will be having a start of contact, that is your point Q will be it will be starting over here and will be leaving or ending this for a particular pair of the teeth. Okay, so what will happen? So at this point P will be having a pure rolling criteria. Very important. So apart from this point, let us suppose if I take any point, let us take this point, and this point will be having a we can say non-pure or a sliding case. We'll be having a sliding of the teeth. Is that clear? It's a very important thing. It's a very important thing to understand this pitch circle. That is why the pitch circle is very important. So it's an imaginary circle where the intersection point of the two circle gives you the pure rolling case. Clear? Fine. Now let us go back to this diagram again. So now you have understood this is your imaginary circle which is passing through approximately at the center of this. Let me remove every line. Now, this circle is known as your pitch circle. This circle is known as your pitch circle. Fine. This red line is known as pitch circle. Okay. Clear? Now, the portion of pitch circle is known as face, and the portion which is lower the pitch circle is known as the flank. The portion on the gear which is upper your pitch circle, this is known as face, and the portion which is lower than that of the pitch circle is known as flank. What will be for internal gears? For internal gears, we'll be having different criteria. Fine. Is that clear? The meshing will be same. The meshing will be same, but you'll be having different criteria. The law of gearing, which you'll be studying in the next class, law of gearing. So we'll be understanding more detail about the law of gearing, which is very important if I want to understand when the two gears are in mesh. Clear? Is that clear? Now, there is one more term which is called circular pitch. Now, what is circular pitch? The circular pitch is basically the distance between two consecutive teeth. If I take this point and the similar point on the pitch circle, this is known as circular pitch. The arc distance is known as circular pitch. Is that clear? Fine. Now, if I do tooth thickness, the tooth thickness will be the distance between on the pitch circle. This is always measured over the pitch circle. This is your tooth thickness. Okay. And if I want to know what is the tooth space, this distance is known as tooth space. This distance between the two space. Okay, clear? I'm repeating once again. The distance between this to this is known as the distance between this point and this point. The distance between this is known as the pitch circle. Clear? Fine. Any doubt? Please tell me if you're having any doubt. This clearance circle, I will tell you when we'll be understanding the involute profile. Okay, this clearance circle is basically known as that portion. This is your clearance circle. This one, the second last circle is known as clearance circle. It's basically used because till this point, if I take the profile of this gear, it is involute profile. So this portion is involute profile, and the last portion is not involute. Okay. Clear? So this last portion is not involute. So we'll be having the clearance circle so that we are not having any interference in it. Is that clear? And if I talk about this distance, the distance between the addendum circle to the dedendum circle is known as total depth, and the distance between the addendum circle to the your clearance circle is known as working depth. So thickness plus space is pitch. Is that right? Thickness plus space is pitch. No, it's wrong, Babu Rao. I'm repeating once again. If I take, let us take this point. Okay, let us take this point. Let me use another again. If you take this point and if you take this point, the distance between these 2 points is known as circular pitch. The distance between this point. Let me write a number so that you can have a clear idea. That let us suppose this is your number one. This is your number one. Let me again, due to some issue, it's not. Yeah, this is number one, and this is the distance between this, like this one, and this one. This is your pitch. Clear? Any shortcut reminders, side, sir? Any shortcut to remind? There is no shortcut, just it's a very basic. The topmost portion of the gear is called addendum, the bottommost is called dedendum. Pitch circle is between the addendum circle, which is the imaginary circle at which there is pure rolling criteria. Okay, now if I talk about pitch circle, your pitch circle is basically this one. Let me use again if it is okay. Yes. Fine, due to some issue, it's not able to make straight lines. Just you need to take this point and this point. The distance between these 2 points is called pitch circle. Fine. The distance between these 2 points, that means this point and this point, is called your tooth thickness, and the distance between this one and this one is known as tooth space. Definitely, what is tooth space? If I say in a layman word, what do you mean by tooth space? The distance between two teeth, that is called tooth space. What is pitch? Pitch is basically the consecutive distance between the two teeth, that is called pitch. And what is the thickness? The thickness is the thickness of the teeth is known as tooth thickness. Is that clear? Yes, one of the student has asked me what's backlash. Yes, Ramesh Mohan is asking what is backlash. Anyone who can tell me what is the meaning of backlash? Backlash is basically, you might have known about interference. And what is interference? Whenever we are having undercutting of the teeth, what will happen? Let us suppose we are having a gear. Okay, we are having a gear. This is your teeth of the gear. Okay, this is second gear whose teeth is very long. So what will happen? There is possibility that it will be cutting the dedendum circle of the gear, because this circle is nothing but dedendum circle. So if the length of the teeth is greater, like it is cutting the base of the dedendum of the meshing gear, that criteria is known as interference, and that is known as the dedendum gear. Clear? Is that clear? Fine. So we'll be resuming the class tomorrow. Let us conclude the session. Due to some issues in the tab, it's not able to have a straight line. So don't worry. Let me rectify the issue. So I suppose now you have understood the different classification. What's the basic classification of the gears? How gears is being classified? How we can transmit power between the two shafts. Fine. So tomorrow we'll be continuing the topic of gear. Part 2 will be having we'll start from this gear terminology. Don't worry, we'll be starting from this heading of gear terminology, and we'll be understanding tail involute profile. Clear? So thank you guys for tooth space is no, it's an arc. Circular pitch, tooth thickness, and tooth space, everything is an arc. I've drawn a straight line, but basically it's an arc. Okay, don't worry, it's an arc. It's an arc. All the three are arc. So we'll be having classes from Monday to Friday, every day 9 o'clock. So I'm extremely sorry, guys. I'm coming in front of you like this because due to Corona, we are bound to take classes like this. So don't worry, when this Corona effect is being decreased, we'll be having the live classes on the smart board. Okay. Thank you, guys. So let us conclude this session. And if I talk about all of you know about the Vision 2021 course which we are having, after the successful launch of the your batch 1, batch 2 has been launched for Vision 2021. We are having live evening classes in which your classes timing will be 7 to 9 and 9:30 to 11:30. Okay, at the night. This is dedicatedly a 1-year course for ESE and GATE. Yes, along the pitch circle. I'm again repeating, all the dimensions are measured along the pitch circle. Okay, if rather it be a circular pitch, it to be a tooth thickness or tooth space, every dimension is measured along the pitch circle. What's the difference between tooth thickness of one gear and tooth space of mating gear? Nothing. It's nothing. Same term, the meaning, just you need to understand the meaning. Circular pitch is the distance between two consecutive your teeth. Tooth thickness is the distance between your two ends, and this I'm writing at like this. This is your tooth space. So tell us more about mechanical subjects. I'll be telling everything, don't worry. Okay, basically our agenda, main motive is because now traveling is not possible. Students are not able to go into the classes and they're not able to go into the colleges. So Gradeup is especially coming live for you at any condition and any scenario. Gradeup will be giving you classes. That is our surety. So like this, we'll be coming in front of you with live lectures on different topics. At present, gear is going on. Tomorrow we'll be having a discussion on gears again. So this is about your Vision 2021 course. And if I talk about the scholarship portion, 50% discount is given to GATE qualified in 17, 18, 19 and 20. B.Tech, IIT, NIT and government will be getting 50%. ESE Prince qualified will be getting the 50%. You can contact to this number. You can mail at this number. You can contact Mr. Anand Pade if you're having any doubt in the course related. And also we are having a flat 40% off on all the live courses we are having for all the branches, not only but mechanical, for electrical, EC, civil, we are having flat off. So if any of your friends is interested in taking up the course, you can definitely share this. And please like this session, share this session and subscribe to the bell icon channel so that you will be having the live class being notified before the class is being started. Thank you guys for joining with me. This is Sooraj Sir signing off. Prep smart, score better, go Gradeup, and please take care of yourself. Don't worry, this will be slowing down. Just you need to take care of it. Don't go out of the home. Just stay connected with us on the online platform. Thank you guys. If you're having any doubt or any feedback, just post the comments in the comment section. Thank you guys and all the best. Bye bye. Good night. Take care.